long properties of isosceles, equilateral, and right triangles. All right. This is our little paper folding thing. Get your little piece of paper out. I'll show you how to hold it. Okay. You have an isosceles triangle right here. You ready, Amy? Can you get your little triangle? Do you have yours out?
Yeah, it's in my hand.
You have an isosceles triangle. Okay. We're going to take it and fold it right along the line.
Isosceles. If I measure it,
well,
then it'll be isosceles.
I did my best to make an isosceles. We're going to fold it so that this triangle, this angle on the bottom, the two angles on the bottom will be right on top of each other.
Oh, I was never good at folding.
Right along in the middle of the top angle up there.
No
Okay?
folding.
So, like that? Yes. Try your best to get it just right. Okay?
I was always
This
the
is not
person
just
who
right
would
when you
like
fold it. That's
mess
no
up their
folding.
folding.
Hmm?
I was always the person in school who would like mess up their folding.
I was
to
always
where
the
it'd be
person that did
completely
it over
off.
and over again until I got
I'll
it right.
help you if you need help. Alright. So right now, I have just folded
I
it.
did it.
No.
And you should notice something actually quite cool just happened. Okay? It is a right angle. That is significant, but not one of our postulates right now.
Is it a perfect
It
right
is
angle?
significant. This is a right angle. It is. And it's not something that we have a postulate for yet. Eventually we will, so just keep that in your mind. You also should notice that these two, I have them marked up here as angle A and angle B. They should be right perfectly on top of each other. That means what? What do you know about?
Congruent.
They're congruent. And we're going to talk, that's what we're going to talk about today. There's something else that's super cool. If you come up here, you just created two congruent triangles right here. So their corresponding parts are equal.
Close enough?
Yes. You just folded it right on top of each other, so you should notice, if these are congruent triangles, we just learned CPCTC. So their corresponding parts should be, this is an advertisement for next time. The stuff you only need to know for today is that these two angles are congruent to the bottom, but because of corresponding parts, that just bisected that.
You can keep going too.
Midpoint. And these top angles just got bisected too.
Maybe not.
All right.
Keep going.
What I need, that will happen. Oh, you're going to do it again? Probably only because of the nice triangle that I gave you, but not all of them like that. All right? So the stuff you need to know for today, are you ready? Are you ready? Let's don't get off on any too many tangents here. All right. We did the paper folding thing. Each person has an isosceles triangle. You folded it down the center. And you should notice that you have two triangles, and those triangles are congruent. Okay? That, for the significance of our lesson today, that says that angle A and angle B are congruent to each other. Here's the postulate that goes with. You had a base angle theorem that you already wrote in your postulate books. Are you ready, Amy? Base angle theorem, you have a picture to draw in there. Let's draw the base angle theorem. Go to get your postulate book open. This is your notes for today. Right next to that theorem, you can draw an isosceles triangle.
Base angle theorem.
Mm-hmm.
Base angle theorem.
Does it have to be exactly isosceles?
Oh,
Okay.
no. I mean, mark it as isosceles and say that it's isosceles, but if it's not perfect, you're going to be okay.
Oh, I don't have the converse in here.
Yeah, I just left it blank for the converse.
Yeah. I didn't know I did that.
We're going to talk about the day. No stress.
I kind of figured you would.
All right. All isosceles triangles work this way. If it's isosceles, if these sides are equal, then they call these the base angles at the bottom. Then the base angles are congruent. This is what it stated that you put in yours. If two sides of a triangle are congruent, that is the definition of isosceles. Then the opposite angles opposite them are congruent. So I like to look at it like this.
I think I did that too.
This one goes down here, and that one goes down here. So those opposite ones down there, or those base angles, are congruent. Okay? So these ones down at the bottom are congruent. If two sides of a triangle are congruent, then the angles opposite them are congruent. Basically, if it's isosceles, the two sides are congruent, and the two base angles are congruent. There's a converse to this. If this is the statement, what's the converse going to look like?
If the angles opposite the mark. If two opposite angles are Oh wait, no. If two angles are congruent, then the two sides opposite them are
There we go.
congruent?
There we go.
Wait.
There we go.
What did you say?
If
If two angles are congruent, or if two angles of a triangle are congruent, then the two sides opposite them are congruent.
Let's try.
Is that right?
Mm-hmm. The same picture can be drawn for both of those.
Two angles of a triangle. Wait, if two angles of a triangle are congruent, then then opposites.
Then the sides. She
Like
said then
the
the sides
sides
opposite them.
Instead of the opposite. Okay.
Mhm.
And the sides.
So we just did the converse.
Wait, then the sides opposite them are congruent.
Yes.
I have a bunch of triangles inside of a triangle.
That's
Yeah.
fantastic. I wonder if that always happens. The triangle that I had happened to be an isosceles right triangle, so you might just do some other ones and see if they always work that way.
The only reason that I knew you could keep going is because this was the same shape as my Pathfinder scarf, and that's how you store your Pathfinder scarves is by triangle of like 500 bazillion triangles.
Here we go. So if these base angles are congruent, then the sides opposite them are also, right?
Yes.
Okay. You'll be writing on your postulate book, and many of you already did it right now. Okay? That is one of the things on your assignment is to write that, so you're already done. Okay, next I need you to get out your assignment. You had on section 4.2, number 25, you did some problems that we're going to talk about. And what you do on your homework actually will help you on future assignments, in particular this equilateral triangle. All right, on number 25 from 4.2, if you still need some more time to get it out, just pause the video and come back. You were asked to take this statement, which is a biconditional, and turn it into a statement and its converse. A triangle is equilateral if and only if it is equiangular. So the biconditional part, the if and only if, will be gone, and you'll have an if something, then something else. So you'll have if a triangle is equilateral, then it is equiangular. Then the converse to that, you're just going to switch the if part and the then part. You're going to leave the triangle word in there. If a triangle is equiangular, then it is equilateral. That means that we have equilateral triangle has all three sides equal. But if it's equilateral, it also has all three sides equal. So let's try to figure this out. If all these sides are equal and they all add up to 180, how much is each one? So all we have to do is take 180 and divide that by 3. And that so happens to be 60 degrees. So each of these are 60 degrees. So you have a 60, 60, 60 degree triangle. This is going to be extremely helpful for you if you'll remember that an equilateral triangle, equiangular triangle, is 60, 60, and 60. All right, let's move on to the next thing. I would suggest that next to that postulate that statement that you have in your postulate book, the one that says a triangle is equilateral if and only if it is equiangular, has this picture in it. Personally, when I'm looking through my postulate book trying to find things that I need because I'm stuck on different items, if I have a picture next to it, it's so much easier to find. If you need to pause this video so that you can draw it, go ahead and do that. All right, we have one last shortcut to proving triangles congruent. I would suggest that you go back in a couple pages in your notes and find that page that we've been listing all of the shortcuts for proving triangles congruent. The next one is hypotenuse leg, or we abbreviate it HL. It states that if a hypotenuse and a leg of a right triangle are congruent to a hypotenuse and a leg of a second triangle, then the two triangles are congruent. Let's get a picture that states this. I want you to notice that we have to have a right triangle for this. And then we have the hypotenuse. Remember that the hypotenuse is the one opposite the 90 degrees. So the two hypotenuses, hypoteni, have to be congruent. And then a leg have to be congruent to each other. On your diagram, you do not have a right triangle. You're going to either have to just draw a new one next to it on your paper, or just make an angle mark on it and just assume that it's right triangle. But you need to have a right triangle for this, and a hypotenuse and a leg. We could have done, instead of doing that leg, we could have done this leg over here as being congruent also, right? I would suggest that you draw this in your Pasha book under the HL congruence theorem. All right, let's do some examples. We're going to do 1, 3, 5, 7, 9 on your homework there. You'll do the odd ones, the even ones. We're going to start off with number 1 right here. We know, we're trying to find the value of x. We know that these sides are equal. These are the base angles. And if the sides are equal, then we know that the opposites, if the angles are equal, we know that the opposite sides are equal. That means that this side is going to go to that side. That means x equals 8. I'm going to let you try number 3 by yourself. See if you can do that one. It's very similar to number 1 we just did. You can pause this video and go ahead and write the answer and check it after you come back. Since this base angle is equal, the two base angles are equal, that means those two sides are equal. That means x equals 7. Let's move on to number 5. Number 5, we have a triangle right here. And it states that it's isosceles, so that means that the opposite angles are equal. So these two angles are equal. We know that now these two triangles are congruent by angle, side, angle. That means the corresponding parts are equal. So 7 equals 2x plus 29. Go ahead and pause the video. Solve this equation and come back. Check yourself with me. Make sure I did it right. I'm probably going to reduce the size of that so that it'll fit there. All right. Let's go to number 7 now. Number 7 has similar ideas. We have one big triangle right there. Since these are congruent, the base angles are congruent. And we already have some marks up here, so we don't want to make them look the same. So we're going to make these littler and doubled. All right. So we have an angle, side, and an angle on both of them. So we know that it's congruent by angle, angle, side. You do, excuse me, side angle. You don't have to write these reasons. I'm just doing that so you understand. That means these corresponding parts are equal by CPCTC. So we can write 12 equaling 2x minus 10. Go ahead and pause this video and you can work on it yourself and come back and check yourself. Come back when you're done. I got 11. Go ahead and check and make sure you did it right. The last one is very, very similar to what we just did. It's just turned on its side. It says that this big triangle right here, since we have these angles there, that means it's big and it's isosceles. So these base angles are equal. Again, we have angle, side, angle. So these corresponding parts are equal. So we can set 11 equal to x plus 23. Subtract 23 from both sides, and x equals negative 12. In class, we didn't have time to get to this because we were running out of time, but I'm going to do number 10. I'm going to do number 10, and I probably will do we'll probably do them all, just so we can you can see them and how to do them. Number 10, we have some isosceles triangles here. We have this triangle right here as isosceles. So that means that since these sides are congruent, these base angles are congruent. And since this is a vertical angle, it's congruent. We have this two sides of the triangle congruent. So these base angles are congruent, not necessarily equal to the others. Since this one is 124 degrees, and it's supplementary with the one next to it, so we can take 180 minus 124. If you need to do that on your calculator, you can pause it and do that here and come back when you got the answer. I got 56. So the measure of this angle right here is 56. That means this over here is also 56. On this triangle right here, we know that they all the angles add to 180. So we have this one left over right here that we're trying to find. So if we add these two together and subtract from 180, we will get the measure of this angle right there. So go ahead and pause it and do that. Add these together, subtract that from 180, and we'll get the measure of the angle. I got this angle right here to be 68. That means that this one here is 68. That means this one over here is 68. That means that number 2, since this is the exterior angle and it equals the sum of the remote interior angles, angle 2 equals 68 plus 68, or 68 times 2. So I got angle 2 equaling 136. Yes, this is a long problem. That means I'm going to set this equal to 136.
So I have 12x plus 4 equals 136. I'm going to subtract 4. So I'll get 12x equals 132. Divide by 12. X equals 11. Let's do number 12 together. Number 12, we have an isosceles triangle here and an isosceles triangle there. So these base angles are congruent. It's vertical, so those are congruent. On this triangle over here, we have isosceles, and this base angle is congruent to that base angle. So all those angles are congruent. This one right here is, these two are supplementary, so if I take 180 minus 74, I will have the measure of that angle right there. You can pause your calculator, pause your this video if you need to use your calculator. I got 106. Now to find these angles, we know they're equal. So, and we know this whole thing adds up to 180. So, if I subtract this, I could have done that one too. So if I subtract this from 180 and then divide by 2, I'll have those. Well, we could have done that a little different. We could have said that these two add up to those and just took the 74 divided by 2. That will work the same. It'll be the same thing as what we were doing. So if I take 74 and divide by 2, I'll get 37, which is the same as this 37 and 37. These three now should add up to 180. If I take 37 plus 37 plus 106, probably should check it. Yes. All right. Remember, these two equaled each other. So this is 37. And this is 37. And so to figure out what number 2 is, it's going to be the same as that 106 because they all have to add up to 180. So 2 is 106. 6. That means that 9x minus 11 is 106. Solve that equation by adding 11. 9x equals 117. X divide by 9. Divide by 9. X equals 100. Just plain old 13. Let's do number 14. The instructions here says determine if the two triangles are congruent. If they are, state how. Right now, I have a right triangle. Notice they're right. So we have an angle. We have, that is the hypotenuse. It's the one opposite of the right angle. And we have a leg here. So it looks as if since we have a right triangle, we can use hypotenuse leg. Let's do this one. State what additional information is required in order to know that the triangles are congruent for the reason given. We have HL here, so it has to be hypotenuse leg. We already know that the leg is congruent, but we have to, because of reflexive, we could say that XY is congruent. In this case, YX. It is assumed there, though. What we do need, we got a leg, we need the hypotenuse. The leg is the hypotenuse is the one opposite the right angle. So we need ZY to be congruent to JX. This is a J right there. And you can see that on your assignment. So, all right. Finished with those examples. Let's review what we've done. You learned that for an isosceles triangle, they have congruent base angles. You drew them in your postulate book. We found out that equilateral triangles are equiangular and vice versa. So if they have congruent sides, then they have congruent angles. We also found out that each of these are 60 degrees. Okay. We learned hypotenuse leg. So if we have a right triangle, we have the hypotenuse, and we have these legs congruent. Okay. We're now finished. Goodbye.